Welcome, Mrs. Mahoney's podcast. This is our fifth one in Unit 3, looking at atomic structure. So I'm on page 15 in our note packets. So today you don't have to write a lot of the notes. I have already written a lot down, so maybe even a highlighter, different color pen. I'm just going to kind of focus on some of the key things I think you need to know about this. Okay, we're going to take our electron configuration and we're just going to add a little bit to the code. Remember I said it was just a math equation, so we're just going to kind of look at where some of these numbers would come from that we could put into that math equation. They're called the quantum numbers. And what it is, it's just one more way in detail to describe the electron. And again, when we supply them these numbers, we could then put them into an equation, but we're not doing that. We're just doing this first step, looking at numbers. So the first number we have is called just the principal quantum number, and it's just n. And n you've already seen. This is nothing new. This is that first number you've put when you are writing your configuration. 1 S2, 2 S2, the coefficient, the big number, that is the energy level. So that could go 1 up to infinity, but the most common one we're going to see 1 through 7. Okay, down the next one then, angular momentum. This is now an L. Again, don't ask me why we were changing that they're adding some of these new numbers, but it's called the angular quantum. It's the number that goes with the orbital number that it is itself. So right here, actually I need to go back to highlighter, this is what you need to know. If you have an s orbital, your L is going to be 0. If you have a p, L is 1. If it's a d, L equals 2. If it's a if it's an f orbital, L equals 3. Now notice right here, come up here, this is very important too when you go up. How many different L's can I have? If you look at it, can range from 0, your S, up to n minus 1. I can't find my highlighter, right there. Star that, highlight that. Your L is always going to be 1 less than the energy. So if I just said, okay, we're only going to go up to n equals 7, therefore the largest L that you would see was a 6. Okay, but reality, we're not going to see that. What did we only talk about? S, P, D's, or F's. So you know that if you're talking about a 1s orbital, in this case n would be 1 and your L would be 0. If you're talking about a 3p orbital, n would be 3, L would be 1. And it's a 1 because p's are 1. So if I'm looking at a 3d orbital, your n, 3, this also is an n of 3, your d would have an L value of 2. Okay, F's. Well, we only have 2 F's. So if I had the 4F, n would be 4. Your F then, it's not the F, your L would be 3 because that's what you give for F's. So these you just need to recognize that 0 is an S, 1 P, 2 D, 3 is an F. Okay, our next one that we're looking at is called the magnetic quantum number. So the key words here, your principal, your angular, your magnetic. So M, at least that makes sense for the magnetic. Okay, you have a range of these. What this is doing is actually giving numbers to each orbital. So if we look at orbital notation, S only has one line. So there's only one number that can be, and that we give it a 0. And so there's a range. It's saying it can go anywhere, and it's right here, to plus to minus your L value. So since I'm looking here that if my S, if it's an S, S has an M value of 0. Therefore, the only L value of 0, the only possible M value is also 0. But if it's a p orbital, this could be a +1 if it's in this orbital. It'll be a 0 if it's in this one, or it'll be a -1 if it's in this one. So that's what that plus or minus to the L means. Since if it's a P, L is 1, that means we're going from +1, 0, -1. So if I have D, D's have 5 lines. My DL is a 2, so my range, this would be a -2 orbital. Excuse me, let's go ahead and just consistent. That'd be a +2, +1, 0, -1, -2. F's, you would have the 7. It would go -3, -2, -1, 0, 1, 2, 3. And the thing is, if you hear me saying sometimes a positive, sometimes a negative, we will get in the consistent always the positives first. But the thing is, when you give the numbers, the key here, it has to be a unique set. So even if you started labeling this with a -1, and you said -1 and switch those, they would still have a unique number. So really, it wouldn't make that much of a difference. But we will start counting with the positive and go to the negative. I know it's a little bit opposite than your numbering line. Okay, the last one I think is the easiest. It's your spin. That's the S. If it's an up arrow you draw, it's going to be a +1/2. If it's a down arrow, you give it a -1/2. So let's just look at some possible what the quantum numbers would be for our first 18 electrons. So that's all we're kind of filling out here on this chart. So electron number 1. And so if we kind of think of this, I'll kind of even right over here. Electron number 1, what would I say? 1s1. Well, that's on the first energy level. And if I'm looking at it, it's in an s orbital. That's why it has a 0 for an L. Well, if L is 0, M has to be 0. The first electron I do is an up arrow. That's why I give it a +1/2. That would be your 1s. And we could even say 1s1. Well, what's the next electron? It's also in the 1s, but we know that this is that second electron. What's the only difference? It's still in the 1 energy level. It's still an s. M is going to be the same, so the only difference in this one is going to be a down, so it's a -1/2. But they're unique. They don't have the same numbers. So then what's the next electron? Goes into the 2s1. So that would be an energy level of 2. It's still an S, so that's why your L is 0. M is still 0. Arrow goes up first, so it would have a +1/2. Okay, what would the 2s2 be then? Well, second energy, still an S is a 0. M is your 0. Difference in going down now. Okay, now we're going to go in the 2p's. Look at this. Kind of helped us out here looking at this. I know that I have 1, 2, 3, 4, 5, 6 electrons can go into that. So think of how we're putting them into your arrows as the arrows are going in. So the first electron is going in, and now we're at a p orbital. That's why L is now 1. This is in the first line that you drew. What do we draw first? We draw them up. So that's why it's a +1/2. So now we're going into still second energy level. L, we're still in the P. So if you look at this, all of these are P's. You know what? All of these have the same L's. P have the same L. So what's the only difference now in my middle line? But I'm still drawing it up. So it's still +1/2. The next one is going into my last line. This is my last line, so that's why I would give it, and it's still going up, +1/2. So if you look, what's the only difference? Because now I'm repeating. So this is the second electron that's going in. These are all still the second energy level. That's not changing. Now it's that second arrow you're putting in, so what's the only difference? They're my down arrows, so they get a -1/2. So after the 2p, what's the next electrons we go into? 3 s's. These are all going into the 3s orbital. And again, if you want to put 1, 2, 3, 4, 5, excuse me, up here, 1, 2, 3, 4, 5, 6, to say which specific electron, we can do that. That was my first electron, second, that's my third, that's my fourth, that's my fifth, that was my sixth. So this is at the third energy level, but I'm back to an S. L is 0, M is 0. First I put in my half, excuse me, my up, which is a positive 1/2. Then what's the only difference? Still on the S, it's going down, so it's a negative 1/2. So then we look, okay, what's the last 8 to finish up our 18? They're going to be the 3p's. How many electron can go into the 3p? 6. So I'll have 6 here. So I know since they're all in the third, they all have the same principal, quantum number. They're now a p. P has a 1 as a quantum number for L. Okay, this is where it's different. What is it? I know that I can go from a +1, 0, -1. These are all my up ones. So since they're all my ups, I know that they're all the +1/2. Then what are we going to do? Come in and put my down arrows, and so those are my negatives. So it just really comes down to getting familiar with it, kind of looking at it. So let's look at some on the back. Another way you could see kinds of questions and test questions, everything is it valid or not? So let's kind of look at these to say, would this make sense? The easiest way I do is to say, could I write this? So let's look at this first one. It's saying that I have n is 1. I'm going to go back to my pen. N is 1. This would be a 1s. If this is an S, this has to be a 0, and this is up. Is this valid? Yes, this would be a 1s. Probably a 1s1. Can I write that? Yeah, that's valid. Okay, look at this one. N1, so we're talking on the first energy level. Okay, this is saying it would be a P. 1p does not exist. Is this valid? No. 1p can't exist. Okay, next one. This is at the second energy level. So this is saying, can I have a 2s? If it's an S, M has to be 0, and this is a down arrow. Yes, that could. This could be a 2s, that it would be the down arrow. We know it'd be filled, but that's the electron I'm talking about, that specific electron. Okay, let's look at this one. This is saying it's a 2, but this is a D. This I know is a P. So this is saying it's a 2D. Does 2D exist? No. This is invalid because 2D doesn't exist. However you want to write it so that you know, no, that's bad. That can't happen looking at that. Okay, this one is a 2. The 1 is a P. And so remember, if we're looking at my 2p, I have 3 orbitals. This is a positive 1, this is a 0, this is a negative 1. So can I have a 2p with a negative 1 and an up? Yeah, that works. What electron would that be? So if I'm looking at the second, it's a P, it's in this one, and it's up. I'd be talking about that if I put it in, I'd be talking about that electron. Okay, this one's a 3D. If it's a D, I have 1, 2, 3, 4, 5. 2, 1, 0, negative 1, negative 2. So can I have a negative 1 and an up? Yeah, that exists. This is okay. Okay, look at here. 3. This is a 3p. That's fine. I can have this as a middle one. Ooh, that's wrong. Only 2 possible answers for us. Up is 1/2. Down is a negative 1/2. No, this does not exist. S cannot be 0. Okay, so let's look here. 3, okay, third energy level. Can I have a 3s? Yes. Well, if S is 0, M, this has to be 0. Because M always has to be 1 less than your L. This is 1 more. That's invalid, so we can't have this. This is a no. L cannot be greater than M. Okay, let's look here. 3s, M is 0, which is good. This is down. This is fine. 1, okay, first energy level. We're trying to put a D at the first energy level. Then we're trying to give this a weird little M, because M should only be plus or minus 2. This is like wrong on many levels. No, this is not valid. Tomorrow in class, we're just going to go through and do some more practicing of this, and really it's just getting comfortable with it. How do we get comfortable with it? Keep working on them and keep practicing it. See you tomorrow.